Hi, I'm Jonabel Hadji Basit, a civil engineering student here in MSU-IIT. In this video, we are going to show you how to perform a slump test. A slump test tells us the consistency of our fresh concrete. It determines and tells us how smooth our concrete is. Now, for the materials that are needed for this test and for the procedures that we are going to undergo throughout this test will be discussed by Nichole Pacoy and Yahya Anugod.
Materials for the test. So, here we have slump cone, trowel, tamping rod, ruler, slump base plate, gloves, and other materials include gravel, cement, sand, and water. Procedures for the test. To start the test, we begin by sampling the concrete. First, checking with the crew to make sure all water has been added according to ASTM C172 and mix it thoroughly. Set up your test area in a place that is free of debris and traffic and make sure your slump plate is on the most level surface possible. Next, put your slump cone on the plate and either clamp it down or stand on the foot pieces. If standing on it, do not step off until the cone is full and ready to be lifted. Subsequently, fill your first layer to 1/3 of the cone by volume, making sure it is even inside the cone. After filling the first layer of the cone, we have to rod the layer 25 times, making sure to cover all the surface area inside the cone, slightly angling the rod to get the edges. Here, unlike other tests, you do not tap the side of the cone because that causes artificial subsidence and your slump will come out higher than it really is. Fill the second layer to 6 1/8 inches or 2/3 of the cone by volume, making sure the concrete is even. Rod the second layer 25 times and this time, make sure you penetrate the first layer by 1 inch. Again, do not tap the side of the cone. Next, fill the last layer up to the top where the concrete is slightly overflowing. Rod the last layer 25 times and penetrate the second layer by 1 inch. This top layer needs to be kept full at all times, so add a bit of concrete if it starts to go below the rim of the cone. Strike off the excess concrete, and if you are standing on the cone, keep it steady and do not get off yet. Pin around the rim of the cone, making sure it is full. If you wish to see where the center is displaced when you lift it, place a penny in the center of the cone. Put your hands on the handles of the cone and push down while unclamping the cone or stepping off of it. Keep it steady. Lift the cone straight upwards with no sideways motion or twisting. The lifting process should take between 3 and 7 seconds. Count if necessary. Flip the cone upside down next to the slump concrete and place your tamping rod on top of the cone and over the slump concrete. Measure from the display center to the rod and record the slump to the nearest 1/4 of an inch or 5 millimeters. The entire slump procedure needs to take place in 2.5 minutes. The results and discussion after the test.
The results of our slump test showed that the distance between the top of the slumped concrete and the top of the cone is 3.5 inches or 89 millimeters. This indicates that the sample falls under Class 2 slump.
Standard specifications for the test.
If the slump value does not fall into the specified slump range, a check test should be conducted on another portion of the same sample. If the second sample also fails the test, the concrete is assumed to have failed the project's requirements as per standard specification for ready-mix concrete or ASTM C94. ASTM C143 also states that if 2 consecutive slump tests fail, the concrete is considered not to have the necessary cohesiveness and plasticity.
For your information,
Concrete workability has a direct relationship with the strength, quality, and appearance of the concrete and its required application. The higher the slump of the concrete, the more fluid it is, and the lower slump results in a drier concrete mix.